So guys, as you can see, our lasers are hitting the target. Both the lasers are hitting both the target. Now I do is that I intercept the first laser. See, the LED turns on only for the first laser. Now I do is that I intercept the second laser. See, the second laser intercepted. It means that PIC knows that someone has intercepted the second laser. So something is wrong. Now again the first laser. Again something is wrong. Now you know that if you install the system with a door, you will install this one laser at the one end, like at the bottom at 1 feet height, and the other laser at 4 feet height. So whenever both the lasers are intercepted, only then it is meant that a person has passed by. So see that these lasers are totally independent. They have separate source. They can be as far away as they want. This circuit is different circuit. It is powered up by the PIC, another source. So guys, now I will intercept both the lasers. Like a person is passing by, and see, now we are in the alarm state. You can hear the buzzer. Now this buzzer is triggered. We are in the alarm state. See, right now, if I intercept the lasers, you will see nothing will happen because we are already in the alarm state. Something is wrong. Something has passed which should have not had passed. Now what we do is that we need to now reset the code, like we are done with the thread. Now we want to reset the code. Now to reset the code, it's very simple. You can simply reset the code by pressing a push button. Now to reset the code, I press this button over here. The code is reset, and now it is looking for the next target. See, again the code is working as usual. See, now when I press both, again now buzzer has been triggered. So this is as simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can make a laser security system using a PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP variant. And guys, these are the two LDRs I'm going to use in this project. Now guys, let's connect these LDRs with the PIC. As you know, LDR has only 2 pins like this. I name the one pin as a signal and other pin as a 5 volt. You can shuffle these 2 pins, like you can take the 5 volt pin as signal and the signal pin as 5 volt. It doesn't matter. Now for the lower LDR, I again do the same. I label the one pin as the 5 volt, other pin as a signal. Now to connect them with the PIC, you will need a 10 kilo ohm resistor for each LDR. So you will need two 10 kilo ohm resistors for 2 LDRs. Now for the top LDR and the bottom LDR, you will common the 5 volt pin of both the LDRs. Then you will send it to the common VCC pin of the PIC. In this way, your LDRs will get the 5 volt from the PIC. Now this will be the V reference voltage. Now guys, for the top LDR, you connect the signal pin to the one end of the 10 kilo ohm resistor. Now from the same pin, you will take out your output. For that, you can use any available ADC pin of the PIC. I am going to use a pin number A0 like this. Now from the other end of this 10 kilo ohm resistor for the top LDR, you will send it to the common ground like this. Now for the lower LDR, bottom LDR, you will connect the signal pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin, you will take out your output. You can use any ADC pin of the PIC other than being used by the upper LDR. So I have A1 available. I am going to use a pin number A1 for the lower LDR like this. Now from the other end of this 10 kilo ohm resistor, you will connect it to the common ground like this. In this way, our LDRs are connected with the PIC. Now guys, these are the KY008 laser modules I am going to use. Now these laser modules, as you can see, they have like 3 pins each. Now the topmost pin, if you hold it like this, is the S pin, signal pin. Then the center one is the positive pin, 5 volt pin. Then the bottom one is the ground pin like this. Now in our application, these two will be installed at some other place. They might be like 10 meter, 50 meter away. They will be the source and these LDRs will be the target. So they will constantly fire laser at the LDR. Whenever someone will pass, if he will cut the laser, then the PIC will understand that the laser is no longer hitting the LDR. So it will trigger an alarm or something, whatever you want. So like this, they will constantly hit the LDR like this. Now let's power them up. So they will be far away. You will need just a power source for these laser modules. Like you can use a battery or whatever you prefer. You can use any source of power like 5 volt. On 5 volt they work. You can use the other type of laser as well if available. Any type of laser will do. So guys, now to connect it with the source, I show you. You short the positive and signal pin like this for both the KY008 laser modules. Then guys, you will need a power source. You can use an adapter or 5 volt supply or a battery, whatever you prefer. And as you know, each power source, whatever you use, an adapter or a battery, it will have only two terminals, positive and negative. You will connect the positive terminal to this shorted signal and positive pin of both the laser modules. Now guys, for the negative pin, similarly connect it to the negative of your 5 volt power source for these laser modules like this. In this way, your lasers will be constantly on, they will be constantly pointed at the LDR and they will be constantly hitting the LDR. So guys, in this way, this laser system will work. Now to add additional accessory, this will be our main board and they will be the additional small boards wherever you want to place them, and this will be our mother main board. So they both are independent from each other. This PIC system and this 5 volt system of laser is independent system. Now guys, let's connect the rest of the components. So we will need two LEDs. This LED, the top one, will only turn on whenever this LDR will be triggered. It means that someone has passed and this laser has been disconnected. Like the laser is no longer hitting the target, then this LED will turn on. Now the bottom LED will be for this LDR, the bottom LDR. So whenever someone will pass by and this laser will not be hitting the LDR, which is a target, then this LED will turn on. So indicating that someone is passing by. Now a person is long enough, so we have two LEDs hitting the target. So sorry, two lasers hitting the target. Both the laser must be cut to trigger an alarm. For alarm, we will use a buzzer. Now guys, let's connect the LEDs first. Now to connect the LEDs, as you know, each LED has two pins. One is longer, one is shorter. Unlike the LDR, you cannot shuffle these two pins. Longer is always the power, shorter is always the ground, like this. Now guys, for the top LED and for the bottom LED, you common the ground pins like this, and then you send it to the common ground of the PIC. Now for the power pins, that is the longer pin of each LED, you will need a 220 ohm resistor. This is basically a safety resistor. You can use higher values as well, but remember, higher the value, dimmer will be the LED. So 220 is an ideal value. So I suggest you use a 220 ohm resistor. Now guys, for the top LED, you connect the longer pin to the one end of the 220 ohm resistor. Now from the other end of this 220 ohm resistor, you can use any available digital input output pin of your PIC. I'm going to use a pin number D2 like this. Now guys, for the lower LED, connect the longer pin to the one end of the 220 ohm resistor, and from the other end of the 220 ohm resistor, you can use any available digital input output pin of your PIC. I'm going to use the pin number D3 like this. Now guys, this push button will reset the code in case someone has passed and the alarm buzzer has been triggered. We will just install the buzzer after this. Buzzer has been triggered or an alarm has been triggered. Then the PIC will remain in alarm state. That alarm will continuously keep on triggering. But you have seen that it was not something that you should be aware of, that that is something normal. Someone has passed by and you know he should be passing by. So you want to reset the alarm, then you will use this button. This will reset your program back to the original state without like switching off the circuit. Like if the other way is you just power off the circuit and power on the circuit. That is not a patterned way to do it. So we will use this reset button for this. Now guys, let's connect the reset button. As you can see that this is just a normal tick tick button, a momentary push button. It has two pins and it is also a non-polar component. You can shuffle these two pins, doesn't matter. I name the one pin as the power, other pin as the signal. You connect the power pin directly with the 5 volt pin of your PIC like this. Just comment it with the VCC of the PIC. And for the signal pin, you will need a 10 kilo ohm resistor. You will connect the signal pin to the one end of the 10 kilo ohm resistor like this. And now from the same pin, you will take out your output. For the output, you can use any available digital input output pin of your PIC. I am going to use a pin number D1 for the button like this. And now from the other end of this 10 kilo ohm resistor, you send it to the common ground. Now guys, this is our passive buzzer. I'm going to use a passive buzzer here. You can use active buzzer here or any other sort of alarm, a better alarm, bigger alarm as well. But for that you will need a transistor. So that's not an issue. I have many videos on it. How you can use a transistor to trigger a load. I will also share the link of those videos in the description. So guys, let's install this buzzer. as you can see, this buzzer has positive sign at one side. See, the pin beneath that positive sign is the power pin, and the pin on the other side where there is no sign is the ground pin, like this. Now guys, you connect the ground directly with the ground of the PIC, and for the power pin you can use any available digital input output pin of your PIC. I am gonna use a pin number C4, like this. In this way guys, our circuit is now completed. Now we can move on to the hardware and the programming. So before we move on to the programming, let me introduce you to the hardware. So guys, as you can see, this is our hardware over here. These are the two laser modules as shown in the presentation. Now you can notice this. This is the separate power source for these modules, while our PIC circuit will be powered up by the PIC3. So these two modules are completely independent from this circuit. They can be as far apart as possible. So like in case of a door, a person is passing by, you will install one at the top, like at 4 feet high, another one at the bottom, like only 1 feet high. So in this way you will be able to detect a person entering, or you can add more LDRs, more targets and more lasers as well. Now see that these are the LDRs I am using here. They are basically 20 mm LDR, easily available in the market. You can use the smaller LDRs as well, but those are difficult to aim with the laser. So see, once the laser are aimed, then there are no issue, like this. Now these are the LEDs I am going to use. Only two LEDs will be used, the most extreme right and extreme left one, and this is the buzzer here, and this is the button I am going to use. So guys, as you can see, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and at the back is our PIC at 3.5. So guys, you can see that only the lasers are active right now from this power source because it's a separate system, and you can use the battery as well, while this circuit is completely off. See, but once the circuit is on, then when I will intercept this laser, then this LED will turn on over here, like this. And when I will intercept the other laser, like this, the other LED will turn on. And when I will intercept both the lasers, only then the alarm will trigger, and alarm will keep on triggering. It will like start to beep. And now if you want to turn off the alarm, you have to use a reset button like this. It will keep on beeping forever, like an alarm has been rang, something has happened. Now only way to reset the alarm, if this is okay, it's normal, it happens, then you have to manually press the reset button. So it is a patented way of resetting your circuit. Instead you power off the whole circuit and turn it on again. That's not a good way to reset a circuit. So to reset your programming, we have installed a reset button. You will simply press this button and your circuit will reset, ready for another interception. So guys, let's get to the micro C4 PIC programming. So guys, this is our micro C4 PIC. Let me zoom in. I have the version 7.2.0. You can use the higher versions as well. Latest is always the better. So 7.5.0 is also available. I have not yet updated to that, but I will update soon. So click on File, New Project. This window pops up, New Project Visit. Click on Next. Write the name of the project. I write, what should I write? Laser Security System Tutorial by Learning Microcontroller. So that's the name of the project I just wrote. Select the path where you want to create the hex files and also store the C files. Select the microcontroller. I'm going to use the PIC16F877A. Click on Next. Also set the crystal. This is the crystal value. The crystal you had attached to the pin number 13 and 14 of your PIC16F877A, and I had attached a 20 MHz crystal. So you write that. I click on Next and Finish. Now guys, this will lead you to this window. Before you do anything else, first of all, save your work by pressing Ctrl S. Now guys, let's go back to the presentation again. This is basically a schematic as well. Here you can see that we have LDRs, then we have a tick button, then we have two LEDs, a D2 and D3, then we have a buzzer. So we have to initialize all of these pins first. First of all, we go for the LDRs. So let's get to the micro C. So to initialize the LDRs, we will need the ADC pins. For that purpose, first of all, go to the right in the libraries, system libraries, check mark the ADC. Now guys, here you write down ADC, capital I and IT, not the underscore. This command initialize all the ADC pin of your PIC microcontroller, give some initialization delay. This initialization delay is not necessary, but I suggest you always give it in the one-time loop. In the previous versions of the micro C, it was not very stable to go without this, but in the newer versions, the codes are very stable, so you don't need it anymore. But I still have the habit. But it's a good practice. You should give some delay in the one-time loop. Now our ADC pins are initialized for the LDRs. Now the next thing is we'll need to initialize the next pin. See in the schematic, I had connected a push button at the D1. So let's initialize the push button at pin number D1. So let me get back to the micro C for PIC. So I write trace d.f1 equals to 1. Like in case of Arduino, you have a command called pin mode input or output. Here you have the trace register. 1 means it's an input, 0 means it's an output. So a button is always connected to an input pin. Now the initial state of the button, port d.f1 equals to 0. Why 0? Let's get back to the schematic again. See that this 10 kilo ohm resistor is at the grounding end. Remember that whenever the 10 kilo ohm resistor is at the grounding end, when the button will be pressed, a 1 will be sent. So if the button is pressed, a 1 is sent, then by default, the pin must be 0. So it's 0 by default. Give some initialization delay like this. Now guys, the next thing, we get back to the schematic and look what we want to initialize next. So we have two LEDs at D2, D3 and C4, we have a buzzer. So we initialize the LEDs at D2 and D3 pin. So let's get back. So just copy this, paste it here, D.F2, make it 0. Now see the difference. It's like pin mode output. So LED is always the output. So the button was the input. So we gave it 1. Now for the D2 pin, we are giving 0 because it's an output. Now also make it D2. Initially, LED must be off. So digital write low. Just like in case of Arduino, you write digital write high or low. Here you will use this command, port D.F2, whatever the pin is. 0 means it's low, 1 means it's high. So by default, it's low. Now for the second LED at D3, that is pin number 22 of the PIC, just simply change these. So both the LED at D2 and D3 are initialized. Now we have a buzzer left. So we initialize a buzzer as well. So buzzer is at pin number C4. So let's get back to the micro C for PIC to initialize a buzzer. Now again do the same, just copy this. Again, buzzer is an output, so just change the pin name C.F4. So a buzzer is initialized on the pin which is declared as output, and initially the buzzer must be off, so C.F4 equals to 0. Now we have our ADC pins for the LDR. We have our button, the reset button. We have our, I give them button, LED 1, LED 2, and finally this is the buzzer. So we have everything initialized. Now we can move on to the forever loop. So write down while 1, forever loop starts here and ends here. Now guys, first of all, we need to write down here our commands with which we will receive data from the LDRs, because LDRs are our main source here. First of all, we will need to read the values from the LDRs. So we will need some variables which will store the values coming from the LDR. I write val, or I write LDR1 and another variable as LDR2. So for both the LDRs we have one integer. Now guys, we go to the right in the ADC library expanded, you have this command ADC read. You copy this command from the example here, paste it here, replace it with your variable. We have LDR1, ADC read from which channel? Channel 0. Now guys, this is the channel. Now LDR1 is connected to the pin number A0. A0 means channel 1. So we are reading value from this. Now if LDR value is less than 700, I take it by approximation. And because LDR is being constantly hit with the laser, it means that LDR is at the maximum value. It is receiving maximum light as much as it can. So if the value, like if it is intercepted, if the LDR is intercepted, then this value will drop. Like it's an ADC value, it will drop below 700 to something like 450, 500, depending upon the light in the room. So you have to do some adjustments here as well. You can play with this code. You can make better adjustment. I will give you this micro C for PIC file with the hex file and all the files that come with this micro C. So I will give you all the files in a Google Drive link in the description of the video. You will open that link and you can download the complete folder. So that will be good. You will play with the code. So as per my room lighting, 700 is enough. So if the LDR value is less than 700, then it will turn on the LED. Like it means that something has intercepted the LDR laser hitting the LDR. So what it should do, it will turn on the LED 1. LED 1 is now turned on because LDR 1 is no longer is hit by the laser. Something has intercepted the laser light hitting it. So in case it's opposite, laser is hitting the LDR, then the LED should remain off. Now do it for the second LDR. Just copy this, paste it here like this, and make it LDR. So we have here LDR2, the other variable, paste it here, LDR2, and now our LDR2 is connected to the channel A1, pin number A1, that is pin number 3 of the PIC. So I write 1. Now read the value from the A1. Here make it LDR1, and the LED for the LDR1 is at D.F3, that D3. So at pin number D3 we have the second LED. Now this is done. Now guys, the next thing is, so first of all we build this code and check it, does it work or not. See, there is an error here. We check what's the error. LDR. So LDR is not our code. This is LDR1. See that we have the variable as LDR1. So we made a mistake here. So let's build it again. See, now let's burn this code. We go step by step and see does it work or not. I go to the file in the PIC16F877A programmer, import the hex file. We just created this file. I click on write. Let the new file write. Let's get to the hardware. Okay, the new file is being written. Let it write up the file. Now when we will intercept the lasers, LEDs will turn on. That's the only thing which is going to happen. So our PIC is on. Now I intercept the first laser. See, both the LEDs turned on. So we made a mistake here. Let's get back. We had made a mistake here. We had just copy pasted the code and we had forgotten to change this parameter here. So D.F2 turns on 1 and here the D.F3 turns on as D.F3 is off. Now this is LDR1 and this was supposed to be LDR2. See that we had made a mistake here. Now we had corrected our mistake. We rebuild the code and I click on write again. The new code is being written. So this is the benefit of going step by step. If you have any error, you can correct it right away. So the new code is being burned. Okay, it's burned and powered up. Let me intercept the first laser. See, only the one LED turns on. Now I intercept the second laser. See, the other LED turns on. That's perfect. Now I will intercept both the lasers. See, both the LEDs are turned on like this. See that? I intercept this laser. Only this LED turns on. I intercept the other laser, only that LED turns on. I intercept both the lasers, both the LEDs turn off. Now guys, we move on with our programming. We are doing fine till now. Now the next thing is to integrate the buzzer. We have a buzzer as well. Now to integrate the buzzer, we have a passive buzzer and a passive buzzer works on a pulse. So buzzer is at C.F4. Now if both of these are on, I told you that if both the LDRs are like not receiving the if the lasers or both the lasers are not hitting the target, only then the buzzer will turn on. Now we write if this condition for the LDR1 is less than 700, paste it here, and means if both are 1, only then 1, else 0. And now write the second condition, this condition. If both the conditions are satisfied, like both the LDR values are below 700, it means that both the lasers are not hitting the target, both are being intercepted, then the buzzer will turn on. Now this is our buzzer here. You copy it, paste it here, make it 1. We need to, this is a passive buzzer. If it was an active buzzer, then this was enough. But for the passive buzzer, this is not enough. You have to give a pulse. Again, a pulse is to send a 1 and a 0. And you give a delay of 1 millisecond, it will make the buzzer just beep. Like this. Now the buzzer will beep. For the passive buzzer, this is the code like this. Now it should be for how long? And in my view, the buzzer must keep on beeping forever. That something wrong has happened and alarm has triggered. And the alarm should remain there forever until a person himself resets the alarm. We built this code and you will see the problem here. Okay, I open the PIC16 programming tool. The file is already selected. I click on write. Okay, now we have integrated the buzzer as well. So buzzer only gets active if both the LDR1 and LDR2 values are below 700, which means that both the LEDs are on and also both the LEDs are on and also the buzzer will be triggering at such a point. Now see that these are our laser hitting the target. I cancel the first laser. See, the LED turns on but buzzer didn't work. For the second LED, still the buzzer didn't work. Now I cut both. See, the code has blocked. So this is a good sign. Let's get to the programming. Okay, we have C.F4 here for the buzzer. It will be repeating here. Now we made a mistake here. See that the buzzer didn't trigger because we have to send a pulse. We just send a 1 for both. So this is wrong. Now we had made the correction. At this point the buzzer must be triggering. So click on write. Again we are writing the code because the buzzer didn't trigger. Okay, the new code is being written. Okay, the new code has been written and circuit is powered up. Now the first target is missed. The LED is on, showing the warning. Now the second is missed. Second LED is on, showing the warning that second laser is not hitting the LDR. So something is intercepting it. Now I cancel both. Now you can hear the buzzer is on. See, the buzzer is on now. So guys, the buzzer is working now. Now the problem is, suppose that you have dealt with the problem and now you want to reset the code. How to reset the code now? Both the alarms are on that something is wrong, but you notice that it was not wrong, it was someone you know. Now you want to reset it. Now how will you reset it? Now we will need that push button over there. Now we need to integrate this button, that once we press this button the code goes back to the initial state. Right now it's not in the initial state, it's in alarm state. See, the buzzer has been triggered and it's in the alarm state. Now we have to deal with this. So for this, what I will do is that I will also program the button. So let's do the programming of the button as well. So let's get back to the micro C for PIC. So this is our micro C for PIC. Let me zoom in. So guys, we have a buzzer and this is a button at port D.F1. Now inside this forever loop, this is a forever loop. This will make the buzzer go forever. That's why we are stuck here, because our code is still inside this loop. Now we want to break out of this loop when this button is pressed. So I write if port D.F1, and I told you earlier that our 10 kilo ohm resistor is at the grounding end. This means that whenever the button is pressed, a 1 will be sent. If the button is pressed, a 1 is sent, then we will wait for it's a debouncing delay, that if the button is accidentally pressed due to any phenomena like static shock or accidentally, then the alarm should not turn off. Alarm will only turn off if the button is pressed for more than 50 milliseconds. Now you have pressed the button and now again it will check for the button to be pressed after 50 milliseconds. If still the button is pressed, then it will break. It will break out of the loop like this. Now it will break out of both the loops and it will go back to the original state, and it will again start looking for that LDR to go down. Then it will look for the second LDR to go down. If both the LDR are down, then this is our alarm state. You can call it alarm state. That both the LDR are down, this means something has been detected and now only way to get out of it is to use this button. Now I build this code, I write this code, let's see what happens. Okay, the new code is being written. Let me zoom out and we get to the hardware. So guys, this is the hardware here, and let the new code write up. Okay, the new code is written and circuit is powered up. Now guys, let's check it. So I place hand in front of the first LDR. See, the LED turned on, indicating that the one LDR is not being hit by the laser. That something has intercepted the laser, something is in between. Now I go for the second LDR. See, it is showing again the same, but our alarm only triggers if both the lasers are missing the target. So now we intercept both the lasers. Now the alarm has been triggered again. See, both the LEDs are on and buzzer is beeping. See, both the LEDs are on and our buzzer is beeping. Now guys, I will press that button over there to reset the code. Now see, this is the button. This is the button. This will reset the code. So I think you can hear the buzzer from here. So guys, you can hear the buzzer. The buzzer is triggered. We are in the emergency state now. Now we need to press this button over here to reset the code. See that? Now I press the button, the code will go back to the original state. Now let me press a button. So this is the button here. See, now it's on, buzzer is off. We are in our initial state. See, the buzzer is off now. You cannot hear the buzzer. Now guys, what I do is that I again test the code. The code is again working as intended initially. I place my hand and intercept the second laser. See, second laser is still not hitting the target and the LED is on. Now the first laser, it's not hitting the target and LED is on. Now I will intercept both the lasers. Now we are in the emergency state. Now the buzzer is on. Now see, this code will not work because it's in the emergency state already. Something has passed which should have not passed. See, the buzzer is on and we are in the emergency state. Both the LEDs are on, buzzer is off, on. And to reset the code like you had done with the thread, now you want to reset the code. You simply, instead of repowering of the circuit, you will press this button over here. Okay, I think you can see it like this. Now I press it. See, now again we are ready for that next run. So guys, this is it. This is as simple as that. I hope you learned something from this video. If you have any questions or queries, you can ask in the comments. So thank you very much for your time guys, and have a nice day.